Wanted to give you a little homework help on lesson 9.3. This is page 616, and the first set of problems, the instructions look like this. The terminal side of theta in standard position contains each point. So here's the point for number 13, the point -6, 8. Find the exact values of all 6 trig functions of theta. So I think a little sketch helps when you're first starting out doing these problems. And this, the one thing about the sketch is that it identifies exactly where this point is. The point -6, 8, of course, would have to be in quadrant 2. And so the problem is describing the terminal side going through that point, terminal side for some angle theta. And so we're going to use a right triangle. So I'm just going to draw up a straight line right down from the point to the x-axis, and we're going to label the two sides that we know. Since x is -6, we went left 6 and up 8 to get to this point. That means that the measurement of this bottom leg would be 6, and the measurement of this vertical leg would be 8, meaning we've got to solve for the hypotenuse, which is pretty easy in this case. C squared is a squared plus b squared. C squared is 100, so C is 10. All right, so now that we have all 3 sides of the triangle identified as far as their measurements, we can now go through the trig ratios, but we got to be careful that we put the correct plus or minus with each ratio to show how these trig ratios are as far as their signs go in quadrant 2. All right, so I'm going to start with sine theta, and sine, of course, is opposite over hypotenuse, and sine is positive in quadrant 2 because, once again, we mentioned this earlier, the y-coordinate is positive in quadrant 2, and you can always associate sine with the y-coordinate of this point on the terminal side. Okay, so sine theta and reduce. So make sure if you can reduce, you do. All right, let's do cosine theta, and that's going to be adjacent over hypotenuse. But remember, just like the x-coordinate is negative in quadrant 2, we associate cosine with x. And so it starts off as -6 over 10, but it can be reduced to -3/5. Tangent theta is also negative because positive divided by negative is negative, and the tangent ratio is opposite over adjacent. So it starts off as -8 over 6, but reduced it becomes -4 over 3. And now we just work on the reciprocals. So for sine, the reciprocal is cosecant. And since it's positive, cosecant has to be positive. So we just take 4/5 and flip it over. And we've got cosecant. And for cosine, the reciprocal is secant. Cosine was -3/5, so that means secant is -5/3. And tangent, of course, the reciprocal is cotangent. And tangent was -4/3, so cotangent has to be -3/4. And those are my answers for problem number 13. Okay, let's take a look at number 15. Now this happens to fall on one of our quadrantal angles, and we talked about this earlier today, that no matter where you are on this the negative y-axis, which is where this point is, any point that falls on this particular terminal side representing the negative y-axis, it's always true, just like in our notes. Look back on your notes and look at what we did with sine, cosine, tangent, and all the reciprocals for the 270-degree angle, because any point that falls on the negative y-axis will have those same trig function values. Okay, so let's just walk through them. Starting off with sine theta. Sine theta is going to be -1. Okay. Cosine theta, just like your notes, is going to be 0. Tangent theta is going to be sine divided by cosine, y over x, and we can't divide by 0. So for this particular coterminal angle, just like the one above it, tangent is undefined. Okay, so for the reciprocals, for sine, that's cosecant. So -1 flipped over, still -1. Cosine secant, you do have to be careful here because you might just think, well, 0 over itself is 0. But let's think about the ratio of secant. It's the reciprocal of cosine, and this is another way of writing the reciprocal. Secant is 1 over cosine. Those are just synonymous. And since cosine is technically 0, we've already established that, we would be like saying 1 divided by 0 to get secant. And since you can't divide by 0, secant will be undefined. And then we do cotangent for this angle theta, which happens to have a terminal side falling on the negative y-axis. Well, remember, tangent is always y over x. For our example in class, we used a radius of 1, so we used 0, -1, but y over x is still undefined. But x over y, that would be cotangent, is definitely defined. 0 divided by -1 is just 0. All right, so those are my answers for number 15. And those are the exact same answers that you got for the example in your notes, 0, -4. So if you got these right in your notes, it's the same answers for 0, -7. It would be the same answers for any point that happens to fall on the negative y-axis. Okay, so I'll just go ahead and finish circling these and we'll move on. Okay, next block of problems. Sketch each angle and then find its reference angle. All right, so let's draw a little XY coordinate plane, and we'll go ahead and label these quadrantal angles. So this starts off at 0, and this is -90, -180, -270, and then all the way back around we're at -360. Okay, so for -250, it's as though we went -180 and then 70 more. Okay, this whole distance here, of course, would be 90 degrees, so I'm just going to go 70 of it and make my terminal side there. Okay, so I'm calling this -250 degrees. Well, in red, I'm going to show the reference angle. The reference angle is always in this range of numbers. It's always between 0 and 90, so of course it's got to be positive. Can't be 90, it's got to be less than 90. So, and it's always formed by the terminal side, which is this side of an angle, and the x-axis. So the terminal side and the x-axis form an angle right here. That fits this description. And just think, how much did we have to go beyond the -180 to get to -250? That might be a little confusing. This is for the quadrantal angle, so let me move that over. -270. Okay, so hopefully you can see that it took another 70 degrees to come up with the -250 angle. And so I'll do my reference angle in red. The reference angle would be 70 degrees. Okay, it's this distance between terminal side of the -250 angle and the x-axis. Okay, let's take a look at number 22, and this is in radians, so that's no problem. We'll just go ahead and identify our xy plane, 0. This would be -pi/2. Remember, halfway is -pi, going in this direction. This would be -3pi/2. Just separate these, don't get confused. And then all the way back around would be negative 2 pi. So we're going in a negative direction. Negative pi over 4, you could think of that as negative 1/4 pi. So we're going in this direction, but only a fourth of the way to pi. Okay, well this would be a half of pi. So a fourth is a half of a half. You can think of it that way. So traveling in the negative direction, I'm just going to split this quadrant in two. Okay, so this angle I'm calling negative pi over 4. Okay, 1/4 of the way to pi in a negative direction. So the reference angle, again, has to be described in this way, and it's going to be between the terminal side of a given angle and the x-axis. So we're talking about this angle that I've marked in red, and that is pi over 4. Okay, that angle here measures at literally pi over 4 radians. And so my answer for number 22 is just pi over 4. Okay, now we're at the last part of your assignment, and instructions say to find the exact value of each trig function. So no calculators here. You won't be able to use a calculator for these types of problems on your quiz or test. I went ahead and wrote these down, but you should, or you could just use this if you like, but I would pull out my notes from lesson 9.1 where we identified all of the functions, sine, cosine, and tangent. We didn't do the reciprocals because we know how to do those, but we at least did sine, cosine, and tangent for the 30 and the 60 degree ratio for this 30, 60, 90 triangle. And we did these for, we called these the special right triangles. This came from this bottom section came from the 45, 45, 90. Okay, so I told you these would really come in handy because they're used a lot. They recur over and over, in trig problems, and you're going to see why they're handy when we do these problems. So let me just walk you through number 26. Cosine 150 degrees. Well, obviously, I don't have a ready-made cosine 150 degrees. I could just go to a special right triangle and just write down. So let's think of a reference angle that would help us. It would take us to one of these that we already know. Okay, one of these familiar trig functions from the special right triangles. So this is where reference angles really come in handy. All right, I'm going to draw 150 degrees. So here's 90 and then another 60. Okay, so this is 150 degrees. So that leaves this angle here, I'll just do 2 red marks, a 30-degree angle, which is called a reference angle. So instead of having to know what cosine 150 is, I'm just going to evaluate cosine 30, which I already know, but I'm going to remember that cosine in quadrant 2 is negative. Okay, so this is putting all of this lesson really together because we've got to know the plus or minus of sine and cosine and tangent within each quadrant. We need to understand reference angles, and we need to understand then how to put all this together. We need to go back and remember our special right triangle functions. So cosine 30 degrees, it's right here in front of me. It's the square root of 3 over 2. But in quadrant 2, cosine is negative. So to complete my answer, I'm going to make sure I put the negative sign in front of this ratio because that's where this terminal side falls. It's in quadrant 2. And cosine is always negative in quadrant 2. Okay, so let's do another one. Secant 11 pi over 6. So let me just draw a little sketch. And we're going in a positive direction. So here's pi over 2. Of course, we start at 0. Pi over 2, pi 3 pi over 2, and then all the way back around we're at 2 pi. All right, so for 11 pi over 6, that's real close to 2 pi, because 2 pi would be 12 pi over 6. Okay? You could think of 11 pi over 6 as a mixed number if it helps. It's 1 5/6 pi. So just think of it this way: if you travel halfway around in radians, then you've gone pi radians. You've almost made a complete circle, because remember, this is real close to 12 pi over 6, which would be 2 pi. So I'm going to show just a rough sketch that 11 pi over 6 is this angle here, which means the reference angle is formed by the terminal side of this angle and the x-axis. So I'll just put 2 lines to denote the reference angle. And hopefully you can see that I went almost all the way around, but I stopped short by pi over 6. Of course, you could do 12 pi over 6 minus 11 pi over 6 if you like to just do some subtraction, but hopefully it's pretty easy to see that the reference angle is just pi over 6. Well, unfortunately, all of my ratios, my functions for the special right triangles are all in degrees. Well, that's not that big a deal, because we learned how to take radian measures and convert them over into degree measures. And this one's pretty easy. I just multiply by 180 degrees over pi. Pi's cancel. 180 degrees divided by 6 is 30 degrees. Okay. Now I just have to remember that secant is the inverse, or the reciprocal, of cosine. Okay? So if I know cosine 30 degrees, then it's pretty easy to do secant. I just take that ratio and flip it over. I just have to be careful that since I'm in quadrant 4, I remember the correct sign, plus or minus, and cosine is positive in quadrant 4. Cosine's positive, sine would be negative. So all I have to do is take the cosine ratio, cosine 30 degrees, and flip it over, and I will have secant. So let me just do that up here. So 2 over the square root of 3, and then I rationalize, and I get 2 root 3 over 3. Positive, because cosine and secant, since they're reciprocals, they should have the same sign, S-I-G-N. Okay, so there you have it. Those are some examples of your homework, and hope that helps. Work hard on it, and we'll check them tomorrow.